So where are we confused? Do you understand why I took anytime there's a variable in the exponent, we have to take a logarithm of both sides to get we want to move the variable out of the exponent. Yeah.
How did you get this? Could you just explain to me how you got that first line, second line, third line? Wait, why are you putting it?
Because I want to cancel everything except for the t.
Oh, so anyways, you're gonna have to divide it by 2.
Yeah.
Can you explain your thought process on how you did it?
Okay.
Shh.
Guys.
I mean, Dan.
All right, guys. Shh.
Looks like every other day
I'm recording this. I'm gonna email it to your parents. How's that?
Hi, Mom. How are you?
Let's see how they feel about your participation. Okay, do you see this formula up top?
Yeah.
Okay, I'm using the same formula. So tripling 7,500 is 22,500. And then I have the same thing in the parentheses.
Wait, why are you tripling 7,500? Okay, that's what
That's what the directions want us to do. Okay, we want to find out the number of years. That means we're trying to figure out what t is. Everything else we already know. Yeah. We know what the rate is. We know it's semi-annually, but we want to solve for t. When t is in the exponent, we have to take the logarithm of both sides to get it out of the exponent. And then, so I move it to the front.
Why is it a 22 times 22? How is that a? Is that the a in the problem?
Yeah, that's a is the resulting amount. I think maybe what you need to do is look back over your notes as well. So,
what? Did we even use our?
Well, now we are.
Yeah. Wait, let's change my calculator.
Yeah, but how did you get 20? Yeah, how did you get
Because it said they count triple. So
It's triple. You want to find
see how long it would take to get to that.
trying to find the time.
But what did you do? 12,000 triple?
No.
Because the initial amount was only 7,000.
Okay, so I'm going to do control divide. We want.
You just plug in the formula and solve it for t.
Yep. So 2 natural log of 1.0275. So round to the nearest 10, so that'll be 20.2 though, if we're rounding to the 10th place. All right.
The table is slightly confused.
Yeah, how'd you get 3? Yeah, how'd you get? Oh,
Get 3.
Hey, everyone, settle down. Guys, come on. Thank you, Leon.
Okay. The 3 came from dividing both sides by 7,500.
And then you just do natural 1.
Yeah. Okay. Now suppose you deposit $1,000 into an account that pays. So this is our principal. 0.073 is the rate. And this time it's compounded continuously.
Which means?
This is the A equals PE to the RT. Okay, there's really just 2 formulas that we need to know for the chapter.
That's it.
Okay.
These 2.
This, because the other one, the one with the population, is actually the same exact formula. Just instead of using A and P, we use Y.
What is that one called? The Y
And
one?
K and R both
Right.
rates.
So I will always use the A equals P or T when it says continuously, and when
Yep.
it doesn't, it just says that it's just normal.
Yep.
I mean, the A equals normal.
Yep.
Wait, why did you put a natural log on the
To get the variable out of the exponent. Watch, we're going to do the same thing here, but this one's going to be easier. So we're depositing $1,000. So that's going to go on the right side. How much are we going to put on the left side? 2,400. E to the 0.073t. Okay, so now we're going to divide both.
So Y equals Y to base 0, E is the T.
Okay, I just said. I said they're the exact same formula.
It's the exact same. Oh, it's the exact.
It's just one is for money, the other one is for population. Okay, so I divide, I get 12/5 equals E. to the 0.073t. Okay. What are we going to do to get the variable out of the exponent?
Natural log.
Okay, I'm going to take the natural log. Yeah.
Natural log, why isn't it NL?
Okay. What happens on the right side? The e goes away. So I have natural log of 12/5.
No, they don't do that. They don't say that. No one says that in the video. When? At what time period?
I'm gonna write another seal on it.
Man, I'm gonna watch this recording later.
Is it better to have it as a fraction or as this? Like I know it doesn't really matter, but
It doesn't matter if it's exact.
like if I have it like let's I don't know. I don't know. I'm just thinking like, is it more accurate as a fraction?
Usually. Okay, so we plug that all in. We get... So- Yeah, so we're just dividing. Okay, so if it's 11.99 and I say round to the 10th, that's where it becomes 12. Okay. All right.
Here you go up. So you put in the calculator, outline 12 over 5 divided, and 0.073 is just 12 over 5. Or no.
That's what we're dividing by natural log of 12 over 5. Okay, well, first, what's the formula that we need now?
Oh, for the
It's the one with E.
Right, so it's...
It's Y equals Y0 EKT.
Okay. Find the constant K. So here we go. In 5 years, half of a 22-gram sample of radioactive element remains.
Alright, so like 5 years is T.
Mm-hmm.
Okay. What is 22? It's 22.
That's just the name of it. Or that's just that's saying we start with 22 grams. It's okay.
Wait, why do you do 1 half? Because it says half.
Half.
So this is the half-life formula. It's just a variation of this formula. Because remember we had a whole discussion
So
about
only-
it doesn't matter how much we start
So it's
with.
only gonna be 1 over 2?
If it says half-life. If it says half. Yes.
Will it say half?
It will it'll say half. Okay, so we're going to do natural log of 1/2.
What happened to Y?
And then we're going to do natural log of e to the 5k.
What happened to Y0?
So again, we had a whole conversation about the why not. It doesn't matter how much you start with. Right? If I start with 100 grams and
Oh, so is the Y0 there?
This
Just
is-
like everything?
yeah, because if I divide, I'm always going to get a half and it doesn't matter what we start with. Okay? All right, so now what?
Don't worry about it.
Alex, stop. So what happens with the natural log and the e? They cancel out. So I get 5k. We're going to divide both sides by 5. So we're going to have natural log.
Oh no. Negative number.
That's okay because it's decaying. So it makes sense that you get a negative number. Okay, we're going to go to 4 decimal places. So k equals negative 0.1386. Okay, write an equation modeling its exponential decay. Okay, do I have an initial amount of what I started with? 22. E is automatically going to go into that formula. We've now solved for k, which is negative 0.1386 t.
Oh yeah. T is fine.
Right, but now we want to come up with an equation so that we could plug in any value for t. Okay? So now they're saying if there are initially 50 grams present, how many grams will remain after 80 years?
So the same thing where we
So instead of 22, we're going to start with 50.
how do you
Because that's the
That was the it says half of a 22-gram sample. E to the negative 0.1386 times how many years? 80. Okay, so now what? We have 50 E to the, I'm just going to take that answer from above, times 80. It's a pretty small number, but remember, what was the half-life again? But remember, it took 5 years to become half of what it was. So think about after 80 years. It should be pretty small. So let's see. I got...
Whoa, this radioactive element is pretty radioactive.
So 0.000763 grams.
Yes.
A paleontologist examined the human femur bone and found that it contained 9% as much carbon-14. So 9% is a 9% is 9%.
I think carbon-14.
The carbon-14, we did the 1/2, but I actually gave it to you here.
So if it just said carbon-14.
Yeah, we're just trying to figure out if there's 9% left, how long, or how, it says, here, find out when the human was alive. So basically, how old is this bone? How old is this? So we're going to take natural log of 0.9 equals natural log of e to the negative 0.00012t. Good, so we get negative 0.00012t. So last, I want to just divide.
How does a natural log? Because
Oh.
L and E is the same thing. No. All of the ones are doing the same thing.
So every word well, that's
Two
we'll have
zeros,
to analyze we'll have to divide by an L, right? 20,000.
You're going to have a natural log that you're dividing by. Yeah. Okay, so it's going to come out to 20,066 years. Okay.
So it's just plugging into the formula
Uh-huh.
for all of them?
Yeah, all these, just use the formula.
Where's the natural log button?
Wait, could you explain 5?
Control and then e to the x.
Oh, yes.
For 5, what formula is that?
It's the same one.
So how does
All of this whole page is using the same formula. Well, no, y0 is 22. Because it's, what do you mean? We didn't use it for number 4 because we already had talked about if it's a half-life, it doesn't matter how much you start with. Listen, if you wanted to put 22 in here, then this would be 11. Right? Half of 22 is 11?
Yeah.
So what would happen if I had 11 equals 22e to the 5k? I would have to divide both sides by 22, but that just gives us a half, which is the same thing that we have here. Okay? So when sometimes it doesn't matter what if you're working with half-life, it doesn't matter how much you're starting with. You always just have half.
You always end up at half.
Yeah. Okay? All right, let's just go to some straightforward solving. Yeah.
For the regular log,
kind of forgot how to do that.
Oh, can you write 16 with a base of 2? Can you write these with a base of 3?
Why?
Like this is 2 to the 4th. This is 3 to the negative 1, and this is 3 to the 3rd, because you want to make the bases the same. So if I can make that.
Oh, I meant 3 to the 3rd.
Oh, right.
Okay, solving equations with e to the x. So first thing we want to do is isolate e to the power.
5x and negative 3x equals 7.
Yeah, so we have 5e to the negative 3x equals 7.
And e to the negative 3x is 7 and 5. And negative 3x equals initial. Natural log
Yeah.
of 7.
So isolate e to the power. Once we have e to a power, now we're just going to do natural log of both sides. So natural log so that's just going to give us negative 3x equals natural log of 7/5. Yeah, so we have natural log of 7/5 divided by negative 3. And we're rounding to the 10th place, so negative 0.1. Pretty small, but that's fine. Okay, now, yeah.
Initial natural log x plus natural log 5. And plus 3 is plus of the natural log 4.
So we can't distribute a plus. I think that you're getting it mixed up with natural log of 5x. What I'm going to do instead, you see how we did natural log of both sides? Do e to the power of both sides. And then what happens on the left side, the e in the natural log, is just x plus 5. So x is equal to e cubed minus 5. I think I asked for it rounded to the 10th. So x equals 15.1.
We should do that whenever there's like we want to have to distribute.
Is the e that comes up when you type in like a huge number of calculator the same e? Is that same e?
It's the same e.
Yeah.
So can you just pull up a little bit?
Okay, now what would we do?
Oh, 2 to the x minus 1 equals 2 to the.
Well, 24 we can't rewrite with a base of 2. Okay. We do that so that we can move the x minus 1 to the front.
Oh, and divide by x minus 1. Oh, wait, no.
Natural log is used to divide those.
Yeah, you can divide the natural log. So we can make this natural log of 24 over natural log of 2. Yeah, so you add 1. So I could just type this in. Natural log of 24 divided by natural log of 2. And then we're going to add 1. 5.6. Yeah. We're all right with that? Yeah. Yeah. Yeah, plus 1 to both sides.
What was it, 5.6?
5.6. Okay, natural log of both sides. So x moves to the front, and x plus 2 moves to the front. Okay, this one's a little more difficult. We definitely did ones like these in our notes. Well, we have to distribute on the right first. So we have x times natural log of 3. This is where we have to get the x's on the same side and then factor it out. Yeah. So if I subtract x natural log of 3, but I leave 2 natural log of 3 on the right side, now I can factor out an x.
Two as an unit.
So now what? Can we divide? We just divide by this whole thing then. So we have 2 natural log of 3 over natural log of 12 minus natural log of 3. Okay. 1.58, so 1.6.
Is there a rule that's gonna be this big?
No, it's shorter.
Like 15 plus percent?
20.
So I think I messed up on the call. Tried to do it.
How much up?
I forgot how to do all like the normal solving law.
Okay. We are going to get there.
Oh, you can get a natural
Okay. Yeah, what do we do for these? We want to pick points that we can plug in. What would be a good number to plug in? -2. So if I plug in -2. All right, so -2, I have 3. If I plug in -1, -3. So if I plug in -3, that'll be -1 plus 5. Careful, because that turns, so that's a 4. What happens if I plug in 0? -8, -3. Okay, our y-intercept is 0, -3. Domain is the freebie. Yeah, just
Y is greater than.
y is less than 5, and the asymptote is y equals 5. So it's going to go like this. Remember, if there's a negative, it means it's going to go below the axis. Good? How about the next one? What would be some good numbers to plug in? How about -1 and 0? What happens when I do 1/4 to the -1? 4 minus 2 gives us 2. Yeah. So 0, -1. Domain is all reals. If we plot this, what's the range and what's the asymptote? About above? -2. Remember, it's always whatever is after the. So this is going to have, and it's going to go like this. Good? Okay. Okay, so if I make this equal to x, How can I rewrite this in exponential form? So little base becomes big base.
1/3 x plus 1 is
Yeah. And then this would be 3 to the negative 1.
negative 3.
Because I want to rewrite it in exponential form. So now if I do 2 to the x equals 16, what's, yeah, 16 is 2 to the 4th. Okay. There's nothing there, which means it's actually a 10. It's a common logarithm. Because 1/3 is 3 to the negative 1. So 10 to the x equals 1 over 1,000.
So then you just know that 3 to the power of negative 3 equals 3 to the power of 3. You do that in your head.
What did I do in my head?
So you got negative 3.
No, I just set the exponents equal to each other. Once the bases are the same, you just make the exponents. Okay, in 17, you don't have to do anything. What do we know about natural log and e? They just cancel, so we just get 2x.
Maybe can you back up the
Okay. All right, now we want to combine this to one.
He's gonna be online.
I think it's already online.
Can you put this view on there too?
So it's just 2x or 0.
2x. Okay, so first thing, I have log base a of 36 to the 1/2 plus log base a of 2 to the 3rd minus log base a of 3. So first I'm taking, remember how you can move the powers to the front? You can move them, because we want to condense this into one. Now what? Well, what's 36 to the 1/2? 1/2 power is the same as square root.
6. Yes.
Was 2 to the 3rd.
No, 8. What? 8.
Okay, now we're going to combine these all in one. What happens with the plus sign? What did the plus sign turn into? Multiplication. So 6 times 8, and the minus turns into divided by. So this is going to be log base a of, what's 6 times 8 divided by 3?
16.
Listen. Could we also just divide 3 into 6 2 times? 2 times 8?
Or you just put it. No.
So every subtraction is divided by 3.
Whatever is subtraction, it's divided. Whatever is plus. Yeah. Okay. This is kind of like the simplifying logarithms. We want to rewrite this. So 1/5 is 5 to the negative 1. And how can we rewrite 5 or 25? 5 squared. So negative 1 equals 4x plus 6. So x equals, good. Is this stuff coming back? This stuff it's not that bad. I mean, it's, yeah. Okay, what can we make the same base with 9 and 27? So we have 3 squared to the x minus 6. On the right side we have, so we have 2x minus 12 equals 3. Are we okay with that? So 2x equals 15. What's the matter? You don't have a calculator for this part, so you could just leave it as 15 over 2. Mm-hmm. So this will just be E equals,
Oh,
or X equals.
basically
And you don't have a calculator, so I can't do anything else with e to the 5th. So we just leave it e to the 5th. The next one. Okay, we're gonna do the same that we did previously. What does the plus sign turn into? So I'm gonna multiply. Now what? What do we notice we have on both sides? So we have x squared plus 5x equals 6.
Yeah, we can make it into a factor.
Okay, so now we're going to see, can it factor?
Squared plus 5x minus 6 is 0.
Good.
Take,
6 and 1.
6 and 1.
So plus 6 and a minus 1. Just x equals 1 because we can't have a logarithm of a negative number. Okay. Now what does the subtraction sign do? So x plus 7. Okay, this one we have a problem because there's no logarithm on the right side. So can I change it to exponential? It's 3 to the 2 equals x plus 7 over x minus 1. We can put that over 1 and cross multiply. So we'll have 9x minus 9. So we got 8x equals 16. 2. And 2 is fine.